Hey there, Elixir user. Have you ever wanted to just use Oban, but you didn't know how? And your boss is telling you that you have to synchronize thousands of HubSpot contacts into your Postgres database or you'll lose your job? Well, the chances of that being you is pretty slim, but I'm here to help you with this particular video where we're going to use Oban to synchronize thousands of HubSpot records into a Postgres. What you're going to need is a HubSpot account, which you can get at developershubspot.com, and you'll also need Elixir, and then the rest of the things we can just add into our dependencies. Alright, so here we're in Visual Studio Code. We've got our project folder opened up, and we're going to start off by doing a mix new HubSpot data sync. That's going to be our program. We'll jump into our HubSpot data sync program. Let's open that up in our code editor, Codium. So now we have our HubSpot data sync project right here. Some things that we're going to do to get started with this: we're going to make a docker compose.yaml because there's some stuff that we're going to need in Docker. We're also going to make a config folder because there's some configs that we're going to need to make. We're going to make a config.exs and a dev.exs and a prod.exs and a test.exs. These are all configurations for different environments with our HubSpot data sync, though primarily we're just going to be using config, which this provides configs across all of the environments, dev, and test, since we're not going to put this into prod. You can do that if you'd like, but I'm not going to be doing that here. Alright, so one of the first things we're going to do is we're going to update the Docker Compose file. We're going to just quite simply do a services, and in our services we're going to have a database. And this database is going to use the image Postgres 17.4, and then we're going to have the restart policy as always. We're going to have the environment variables be that we'll have a Postgres user with the Postgres as a username and a Postgres password with Postgres as the password. If you were doing this in prod, you would not want this username or password to be this, because it's kind of a default, leaves it open to being vulnerable. We'll define some ports where we're going to have the target 5432 be published to 5432. This means that our local host should be exposing 5432, and then we'll have our protocol be TCP and our mode be host. So in this way we can have local services such as our Elixir project connect to this Postgres, and we will have this Postgres be available just simply through Docker rather than having to run a Postgres on our host. Okay, now that we've got our Docker Compose YAML all set up, we're going to need to set up some dependencies. Here I'm just going to copy and paste what the dependencies are. I would encourage that you pause and take a look at what we're adding. We're adding ecto.SQL and PostgreSQL because these things are required by ecto, which will connect us to our Postgres. We also have Oban, which is going to be utilizing ecto. We're going to be using Tesla, which is a HTTP client for us to be able to make requests to HubSpot. We'll be using JSON to be able to decode those requests. It's a requirement of Tesla. We're going to be using the Mint adapter, which is part of Tesla. We'll be using Hammer. Hammer is a rate limiting library, so we can set up our program to protect itself from hitting rate limits on HubSpot. And Oban also requires Igniter, So igniter is going to be here. And then we have mimic, and mimic is going to be for doing test mocks, if anyone is familiar with mocking. I'll go into it more in a bit. Okay, with our dependencies added, we're going to open up our console. We're going to do mix.deps.get to get our dependencies. And then we should be ready to continue. Okay, now that we've got things set up, what we're going to do is we're going to put together some configs. So we're going to go into our config.exs and we're going to import config. This gives us the configuration tools in Elixir. We're going to say in our configuration, we're going to config our HubSpot data sync program, and it's Oban. And we're going to configure this Oban with an engine. That's going to be oban.engines.basic. We're going to have our notifier be using oban.notifiers.postgres. We're going to be using queues, and these queues are going to have a default of 10. And we're going to use repo, and our repo, this is going to be like our Oban. Our database is going to use not Oban, HubSpot. This is going to be HubSpot datasync.repo. Cool. And then we're going to config the HubSpot data sync with Oban. HubSpot datasync.repo. We're going to say that this is going to be a database that's going to be called HubSpot data sync. We're going to have a username that's going to be Postgres. We're going to have a password that's going to be Postgres. Just like in our Docker compose, we're going to have a host name that is local host. We're almost done. We're going to have a config. We're going to config the HubSpot data sync where the ecto repos are going to be our HubSpot data sync. It's going to be a list.repo. And then we're going to have a config HubSpot data sync. We're going to give it our HubSpot token. We're going to set that as a env variable, system.getEnv, HubSpot token. HubSpot token. Yep, that looks right. And then for the other environments, we're going to import config. We're going to give that our config environment, such as dev, prod, or test.exs. So that way, in addition to this config file, we also get the configurations for specific environments. Alright, so the next thing we're going to do is we're going to fill in our dev.exs. I'm going to once again import config, and then we're going to config our HubSpot data sync with HubSpot data sync.repo. We're going to configure our repo where this time, and I'm just going to copy and paste this, we're going to have our database be our HubSpot data sync dev database, and Postgres as our logins, and our host is going to be our local host. And then we are going to add in a config for our Oban in our dev environment, where in this case I'm going to say let's use a cron. This will be useful for people who might want to synchronize on a regular basis. And we're going to do a 15-minute sync every time. You can see that here with our cron labeled as 15 minutes. And we're going to have that run our consume contacts worker when we get to making it. In our prod.exs, we're just simply going to import config, and we aren't going to do anything here. If you want to do a setup for your prod environment, I encourage you to do so, but also do so responsibly by making sure that you're setting up proper security stuff by not using, say, like the Postgres username and password and other things. Make sure to do your prod setup specifically. And last, we're going to write in our test config. So we're going to start again with import config. We are going to config Oban, HubSpot data sync, the HubSpot data sync.repo, and I'm just going to copy and paste this next stuff here. Actually, you might want to review this as I go and copy and paste. So what we've got is we're setting up our test database as our HubSpot, let's call this data sync test, Postgres localhost, but specifically what we want here is we want to use Sandbox in our pools, and this allows us to be able to do testing, such as testing Oban, since it's utilizing Ecto, we want it to put things into the database that it will be putting in, but then when we're done testing, we want things to be cleaned up so that there's not just like a messy database, and if we run the program, we don't want the program to be in the dev environment and referencing our test database and then executing things that were put in there by testing but not intended to actually be running. If you get what I'm saying. Last, we're going to do config HubSpot data sync Oban. We're going to do a testing manual. So just a little bit about testing manual. This is a configuration for Oban where when jobs are inserted into the database, they can be verified and executed when we desire. This mode is more advanced and trades simplicity for flexibility. Personally, I like it. The other way we can use is inline, but for this example, we're just going to be using manual. All right, and that completes most of our config setups. Now we want to get into the real meat and potatoes of this. I know you've all been very excited. So we're going to go to our lib, and we are going to add a new file, application.exs, application.x. If we had told our setup to use supervisor, we should have this by default. In this case, I didn't say that, so we're just going to have to write it by hand. We're going to do def module HubSpot data sync.application, and we're going to tell this to use the application module, and then we are going to add impl true, and we are going to def start with a type and an argument that we don't necessarily care about for this. When we do the starting, we'll make our children that get started under the application be our HubSpot datasync.repo, which we need to make our repo file. We want to use HubSpot datasync.HubSpot rate limit. This is going to be our hammer when we get there. And then we want to have Oban use application.fetch env with the bang. We're going to say that we're going to fetch our HubSpot data sync Oban, and that should add all of our children. Last, in our start function, we'll want to put in some options, which here we're going to use the strategy. This is default stuff, 1 for 1, and name Oban, sorry, not Oban, HubSpot data sync.supervisor. I always start with Oban ETL or Oban HubSpot ETL. It's because it's the reference project for this video. Honestly, the easiest way to make videos is make a reference project and then remake the reference. Finally, we're going to do a supervisor.start link children and ops. So this makes our application file. And the last thing to really top off our application file is to go into our mix.exs, and then we're going to add in the application folder here a mod for the HubSpot data sync.application, and we will give it no arguments. So in this way, when the program starts, then it should hit up this application module and then start all of these children here. But these children, if we were to just do IEX-S mix and run it, would fail because we don't have repo or our rate limit, or, well, actually Oban should be set up here, but we don't have our repo and our rate limit, so we're going to need to set those up next. So let's start with setting up our repo. This is to help finish off setting up Ecto, so this is going to be pretty easy to finish. We'll make our repo.ex in our lib folder, and then we'll def module, and we'll call this our HubSpot data sync.repo, and we'll use ecto.repo in this module, and then we're going to give it some configuration parameters such as OTP app is going to be our HubSpot data sync application, and our adapter is going to be ecto.adapters.postgres, and that effectively sets up our repo file. And so next we can move on to making our hammer file. So our hammer file is going to be really easy. We're going to do a new file in our lib. We're going to call it our HubSpot rate limit.ex. Def module HubSpot data sync.HubSpot rate limit. Is that all one word? Yeah, that's all one word. Rate limit. And then we're going to just simply use hammer, and our back end is going to be an ets table. We can talk more about ets in a different video, but essentially what it is kind of a in-memory database, just like Redis. And that sets up our HubSpot rate limit file. So this one was super simple. Let me go and double check our application just to make sure that, yep, and this is what I was looking for. I want to make sure that this is labeled correctly for our rate limit file, just like that. So here you'll see that I wrote rate limit with a capital L, and I changed it now to a lowercase l to reflect our rate limit file. So that completes that. Next, we should set up our client, and then we should set up our Oban worker, and then we should set up a contact schema that will take in, it'll basically represent the HubSpot contacts that we'll be syncing out and putting them into our own contact schema in our Postgres. Okay, and just a minor detail that I've been noticing as we've been making these files is that every time we go to def module, it's not def moduling the way that I think it would. We wanted to start with this HubSpot data sync, so for us to be able to do that, just for our own convenience, we're going to make a new folder in our lib called HubSpot data sync, and we are just going to move our application, rate limit, and repo into that folder, and that should simplify things a little bit more. So now when we go to make our client, we're going to do our HubSpot client.ex, and then we will def module, and boom, we got the beautiful autocomplete. Alright, so in our client, to start, we're going to set a module parameter, a module attribute, if you will, HTTPS for our base URL, which is going to be api.hubapi.com. So we now set up a module attribute for our base URL. Now we need to set up our client, our Tesla client. So we'll make a private function called client. And in this, we're going to use tesla.client to make the client. And we're going to give it a few things to define what our client is going to be doing. The first and foremost thing we should add is our base URL. So we'll tell Tesla that in the middleware for base URL, our base URL is going to be our module attribute base URL, that api.hubapi.com. Next, we're going to use tesla.middleware.bearerauth to be able to put in our token, our HubSpot token. And we're going to need to define a private function that gets that. So we'll make a private function called HubSpot token. And in this token function, we're going to make it use application.getEnv from our HubSpot data sync app. This is going to be getting one of our config variables. If you remember, we set up our HubSpot token. So now if we have in our system environment variables our HubSpot token there, when the application runs, this should run too to get the HubSpot token, and then we can make our calls and be authenticated. Next, we'll want to add tesla.middleware.json. The reason why is because this is more of a convenience thing. This will take JSON responses and then parse them and decode them appropriately. So that is to say, if we make a request to HubSpot and it responds back with some JSON, instead of getting a JSON string, Tesla should transform that string into a whole object in our system, one that we can interact with, like object.property, stuff like that. It's a convenience thing that just it's essentially doing like JSON.parse, if you're familiar with JavaScript, for us. In Elixir land, it's basically doing JSON.decode for us. So that is a convenience for sure. We would like to have that. And then we're going to also add tesla.middleware.logger. This will make Tesla produce logs when we make requests and get responses, and we can see those flying through in our console when we start playing around with this app. And now that we're here, I think that the next thing that we can do is we can go ahead and just start making our function that would be calling HubSpot. I encourage you to go look at the HubSpot API docs for more information about what we're going to be doing here. What we're going to do is we're going to make a function retrieve contacts, and this should mimic or look very close to the documentation that's on HubSpot for their calling this endpoint. So we're going to make our function retrieve contacts. We're going to do a case on this to check our hammer rate limit before we go and make the call, which means that we have to make a function for that as well. So we'll make a private function check hammer my A key, hammer rate limit. And in this check hammer rate limit, we're going to use our HubSpot.datasync.HubSpot rate limit.hit, and we're going to hit it with our HubSpot token being the hit key. That way we know that for this token, we're hitting specifically for this. The scale is going to be a timer that is going to be in seconds. So we'll do timer.seconds, and in the HubSpot rate limit documentation, they say that per 10 seconds, you can do 100 requests. And so our scale is our 10 seconds, and then this final parameter you can see here in this doc that's showing up here in my Codium, the limit 100. So in this way, we're mimicking the HubSpot rate limit of, hey, in 10 seconds, you can only make like 100 requests. This way we have our rate limit all set up. That way, if we do go over that and we hit HubSpot and get like, essentially what shouldn't happen is we shouldn't make a request to HubSpot and then get hit with like a 429. Hammer should be stopping us from making requests that are beyond our rate limit. So this way we kind of protect HubSpot from ourselves. Last, to finish up our retrieve contacts function, we're going to do an allow, and we don't care about the allow count, so I'll just leave that as a commented variable there. And then in our allow, we're going to do tesla.get, and we're going to get our client, and we're going to use the endpoint CRM, v3, objects, contacts, and then we are going to have a function to process our response. So we need to define that as well, but let's define that here in a moment. Let's do the case when Hammer is denying us. So when Hammer denies us, we'll get a deny and a retry after, and with this we're going to simply just return an error, and our error object is going to be a rate limit with a message that should equal try again in our retry after time milliseconds. And actually here we don't need this commented variable. Okay, and so we should add our process response function next. So when processing a response, we're going to do a def.p process response, a private function, and the responses that we expect from Tesla are going to be something that's like an OK with a tesla.env structure, and that struct will have a status and a body to it. So we're going to status and body, and we're going to write our do, but to kind of make this function a bit more robust, we'll say robust, we're going to say when the status is not in 200 to 299, so this one's going to be an error catching one, then we'll produce an error with the body, whatever HubSpot tells us, you know. So we made a request, we get back a response, and if that status is not in 200 or 299, we know there was something wrong with it. And then next we'll do our case when everything goes fine, process response, we'll do OK. Again, it's going to be a tesla.env where it's going to have a body. So assuming that this one is catching everything that is not in 200, this one is going to be things that are in 200. So we'll take our body and then we will just OK and give back the body. And so this more or less makes our client module. And because we're going to need this later, we're going to add to the get a query that's going to take in some params from this params object right here. So we'll go into that a little bit more when we get to working on our worker, which we should work on next. Okay, now that we have gotten our client all finished up, we can go ahead and make a worker. So we're going to make a new file, call it consume contacts worker.ex. We'll do def module consume contacts worker. We're going to use oban.worker to turn this into a worker module, and then we're going to define a perform function. The perform function is what we want the Oban worker to do when it is doing something. This is the thing to perform. So we're going to @impl oban.worker, and then we will define our perform function where we're going to take in a Oban job, and we won't give this Oban job any arguments. We'll give it an empty map. So in this perform function, when we have given the Oban job an empty map, what we're intending to do is just to get the pagination rolling. So with this, we'll do a with OK response from our HubSpot client dot retrieve contacts. You'll see that now we've just added our HubSpot client as an alias. So when we get an OK response from retrieving contacts, then we will take the results out of that response and we will also take the paging information out of that response and then we will check and see if the paging is nil. This is because if there are no pages to paginate, HubSpot won't give us a paging key in the response. So when we try to do that map get, you'll see that map get returns a nil if there is nothing there. So if there is no paging response, then we will store the results, or else we will queue the next page and store results. We'll give it the paging information and the results. So now we need to make our functions that store results and queue getting the next page. So we'll make our store results function first, def.p store results do. Here we'll do an OK results and pipe that into an enum.map where we're going to take each of these HubSpot contacts and we are going to take the contact and reform it a little bit where we'll have an external ID that's equal to the contact ID that we get from HubSpot, and then we'll also have some properties that come from HubSpot as well. Then we will contact create contact. So we'll have to make a contact file here in a little bit. HubSpot data sync.contact. We'll have to make that. Next, we're going to make our queue next page and store results function. So we'll def.p queue next page and store results. And we're going to do a little fun stuff with this one. We're going to do paging results do. The fun thing that we're going to do is we're going to use the task.async stream module. This way we can say here are some things that we want you to do, and you can do these things using just child workers of our Oban worker. So we'll tell it that we'll have a function that will queue the next page and takes in our paging information, and we will also have a function that will do the store results and take in the results. And then when our task goes to do these things that are being enumerated on, we'll just say for your function, take that function and just execute it like this. So now we have a task async stream that will spawn child processes to do the queue next page and store results separately as two different processes. And then we should make our queue next page function, which will take in the paging information. And for this, we'll say to take the module, do a new, and here's the paging information. So now we're saying, hey, take this Oban worker, make a new one, but the arguments are going to be our paging information. And then we will oban.insert that. And because we have set up a separate thing for this worker to do in terms of getting paging information, we'll make a new perform function, but this time our perform function is going to take in our paging arguments, which are going to have a next, and that next will have a map that will have an after. It'll also have a link, but I'm going to use the after. And because after is a keyword in Elixir, I'm going to call it v_after. And we're going to say that when we get an OK response with our after, v_after. So when we get a response using our after, we'll do kind of the same thing. We'll get our results, we'll get our paging, and then if the paging is nil, we'll store those results because we know we're on the last page. Otherwise, we will move on to the next page, get results, and store them. So in this way, we've kind of made something that's a little bit more recursive than before. Let me see what's going on with this. Oh, this is supposed to be args, not arg. So I'll change that there. But yes, so now we've got something that can loop. So we'll go and just say, hey, get me the contacts. This would be like the first page of contacts right here. If, well, it should have results. If it doesn't, then nothing will get inserted. But if there's results, then we'll store those results. If there's some paging information, then we'll queue the next page and store those results. And when we queue that next page, we're making a task, just some little child process that will go and just insert the next Oban job, and another one that will spend the time storing the results. And every time we have a worker being made with these paging arguments, next and after, then we will send that to our client with the after parameter, and then we will get some result back, either more contacts, more paging information, and if we don't get any more paging information, we just store. Otherwise, we queue the next page. So now we should finish things by making our contact. Okay, so next we should make our contacts module. For this, we're going to have to do two things. We're going to need to do an ecto migration and make the contacts module, the contact schema, if you will. The migration will be super easy. What we can do is we can open up our terminal here, and we can do mix ecto.gen migration, and we'll call this migration create contacts. And so we should get a migration out of this if I wrote the command correctly. It might take a while because you can see here that I'm going to have to compile a couple of things. So I might just skip ahead to when this is done. Okay, so this got done, and you can see here that there was an error where I've configured Oban HubSpot ETL in the configuration file, but it doesn't exist. So let me just go ahead and take a look at these configs to make, yep, right here. So right here, we don't need that. We'll just, so you'll see here in dev, I called it Oban HubSpot ETL, when actually it should be HubSpot data sync. And then let me just check our test. Okay, that looks fine. So that, we just fixed that. We've also added our migration. So let's go take a look at that. So now for our create contacts migration, we're going to do a create table in the change function, where we're going to make a table called contacts. And in this table, we're going to add an external ID that is a string, and we won't allow it to be null, because we want to make sure that that external ID is there. And then we also want to add our properties, and we'll make that a map. So then in our Postgres, this will store basically as a JSON blob, column of some sort. And then we will create a unique index on our contacts table where we want to make sure that those external IDs are going to be unique. That way we don't get duplicates of contacts from HubSpot. Now that we're this far along, let's go ahead and make our contact schema. So to make our contact schema, we're going to make a new file in our HubSpot data sync folder. We're going to call it config.exs, and then we will def module contact, and here we're going to bring in a couple of things. First, we're going to alias our HubSpot data sync.repo, and then we are going to use ecto.schema, and we are also going to import ecto.changeset. Now the first thing that we're going to do is we're going to define that schema. So we'll do a schema contacts do, and we'll have a field that is an external ID. It is a string. So when we're casting the external ID, if it was a number, it should become a string in all cases. If you want to do something different, you totally can. And then we'll also do a field properties, and that's going to be our map. So then when we're casting, that should usually cast to a JSON blob, unless there's something wrong with the data. But if there's something wrong with it, that's on HubSpot. And then it's on us to make the changes to our program appropriately. Anyhow, so next we're going to make our change set function. For people who are not familiar with Ecto, change sets are a way of validating data as it comes in to make sure that when you are making a schema, that the schema follows some parameters and is validated properly. So what we're going to do is we'll def change set, we'll take in a contact if we have one, and we'll give it some parameters if they're there. And here we're going to take that contact, we're going to pipe it into the cast function, where casting takes properties of the contact and then turns them into, properties of the params, and makes them what we've defined here. So if we get an external ID, it should become a string. And if we get properties, they should be a JSON blob. So that's what we want those casted to. Then we're going to do a unique constraint where on that external ID, this way, if we find anything that is not unique, it shouldn't pass the change set and wouldn't get put into the database. And then the last thing that we want is to validate required. And we want to make sure that that external ID is there in all cases. So next, we'll make our create function for creating a contact, where we'll give it some params. And we'll say on this one that, hey, when you're creating a contact, take the module, put it into the change set. So this would start with a blank contact schema as defined by our module. We're passing it into the change set with the params that we would get from HubSpot. And then if all of that is good, then we'll just HubSpot data sync.repo.insert. And insert will only insert if the change set is good. If it's not a good change set, then it won't insert. Last, just for our own debugging, we'll make a list function where we'll just do a repo all, and we'll show us all of these contacts using the module. So at this point now, we have a pretty completed program, but we haven't ran it yet. If you are somebody who's likes doing that iterative process, and if you were just figuring this out from scratch, you would be doing an iterative process, then you would have seen errors going along all the way. Because I'm using a reference project and then remaking the reference project for this video, we haven't seen a whole lot of errors yet. But let's go ahead and test our application. So to test our application, we're going to need to get our HubSpot key. Here you can see my developer HubSpot instance. You can make these things for free. It's awesome. Where we've got about 1,002 records in here. We're going to get our key by going up into our settings here, going to our integrations and connected applications. And here you can see I've already made one a while back. So I'm just going to click on that one, and we're going to get our key from this one. So we'll go to auth. You see that the auth key is there. I'm going to be hiding this key because I don't want people to take my key and use it. I'm going to copy it, and then we're going to go into our into our terminal, and we're going to do an export. Sorry, not export. We're going to set the HubSpot token. I think actually we do have to do an export, don't we? Export HubSpot token is going to be our key. So then we give it our key. We can then check that that's an environment variable by doing an echo HubSpot token, and see we get our key. So now if we go and start our application, things should work right. Let's see, we got an error. Could not start application. Invalid value for plugins. Okay, so once again, I must have done something wrong here with the naming problem from copying basically a reference project. So let's see, right here, this needs to be called HubSpot data sync. Let's go ahead and mix again. Okay, and so now we're getting errors because we don't have our database table. So to make our database table, we're going to do a mix.ecto.create and mix.ecto.migrate. That way we create the database tables and then do our migration. You can see here that the database has been created, and now we've added a table for contacts and created our unique index. So we'll go ahead and try starting our application again. We can see that the Oban peers table is undefined and leadership is disabled. So that means that we did something wrong with setting up our Oban. So on our Oban documentation, there's a semi-automatic installation where we need to run mix.oban.install, which we haven't run yet. So we'll go back into our terminal and run oban.install, and this adds the, let's see, Oban.install, igniter, inputs. Proceed with the changes, yes. Okay. So let's do that. So now we've got our add Oban table, and we'll go ahead and run mix.ecto.migrate. So then we now have made our Oban table here. You can see that this is all of the stuff needed to make that Oban table. And let's see if we can make this work now that we've done our oban.install. So I'll mix, and cool. Now we've got no errors. So we've made it. So let's go ahead and try out our worker. We'll do in our terminal HubSpot data sync.consume contacts worker.new, and we'll give it that empty map like we defined in our function here to be able to get that first page. Whoops. There we go. Okay, cool. So we see that we've made the job, it's valid and everything, but we didn't actually insert it. So I'm going to oban.insert to put it in. And now we've got it in the database, and we can see that something happened with it. Let's see. Warning, unexpected. Expected the perform to return one of these things. Might have to spend a little bit of time debugging this. Let's see. Oh, you know what? I see what's wrong now. So on our stream, you see here, we've received a function task build stream. That means that although we made our task async stream, we didn't actually execute it. So we're going to add on the stream a stream.run to be able to run the stream, and then we're going to go ahead and just do this again. So we'll make a new and Oban and insert. Oh, we need to recompile, sorry. So let's see, we recompile. This is Steam stream. Whoops. Let's recompile again. And then there we go. So now you can see our workers are going and just getting Oban results, and they are just putting it into the database. All of those green logs that you're seeing are database entries going in, and we'll just wait for the thing to get through the work that we've defined for it. Okay, cool. Looks like it got done pretty quickly. So to verify what we've got now, we're going to use our HubSpot data sync contact module. You will remember we've got a list function. So we'll take that list, just list off records. And so here we can see, oh, here's like a ton of records. And so we'll take that list and then enum.count. And boom, you can see that we've now got 1,002 records from our HubSpot, which had 1,002 contacts in it. And now that we're this far along too, and we can go ahead and check our validations. So we'll just go ahead and run this again. And you'll see that we get a query error now, and this is because these contacts are getting got again, and as they go through the change set, they're not passing the change set. So we're not getting new contacts. None of these should be duplicated. So we'll do a list and count again, and boom, we've got 1,002. Alright, and one last thing before we move on to writing tests. As you recall, this program did have a cron, where that cron should execute every 15 minutes. And so we are coming up close to that 15-minute time period. So I'm just going to sit here and let the program do its thing. We're about 6, 5, 4, 3, 2, 1, and now it is going. So we've let a 15-minute cycle go, and it is now getting the contacts by itself. This is awesome. So now if you had the requirement to be synchronizing these things on a regular basis, you can be, by having the Oban worker work every 15 minutes. And we can go ahead and list and count. And boom, we didn't get any other duplicates. We still have the 1,002. So next, we should make some tests. Okay, next we're going to set up our test helpers file. We can find that in our test folder. Right here, test helpers. And right now it just has ExUnit start. But we're going to add a couple of things. First, we're going to add our mimics. That way we can have mocking for our tests. So we'll have mimic.copy. We're going to have it copy Tesla. Although Tesla does have mocking, but for this video I'm not going into that yet. Mimic.copy, which will copy our HubSpot data sync dot HubSpot client, and mimic.copy HubSpot data sync dot HubSpot rate limit. So now we've got a way to mock these things in our tests. And the last thing we're going to add is our sandbox mode, which we'll use ecto.adapters.sql.sandbox.mode. And we'll use HubSpot datasync.repo and manual. In this way, we set up our sandbox to run in our program, so then in testing, things can get made and then they'll get destroyed, and we don't have to keep holding on to a whole bunch of test data. And then with the mimics, we can have some mocks. Okay, next we're going to be updating our mix.exs file because we need some Elixir compile paths that aren't there. So what we're going to do is we're going to add an Elixir C paths key to our project here, and then we'll give it the function Elixir C paths. That's going to take in our mix env, and then we're going to define those functions down here where we'll say def p Elixir C paths, and in our test environment we're going to do we're going to say to compile our lib folder and our test support folder, and if it's any other path, then we will just do our lib folder. Alright, so next we're going to set up our support repo case. You can see here in my test folder that I have a folder support and our repo case X module already made. If you don't have it, you just need to make the folder and add the repo case. What this does is we're going to be setting up a ExUnit case template. That is where the things that we define in it will be applied to the rest of our testing suite. So first we're going to def module HubSpot data sync dot repo case, and then we are going to use ExUnit dot case template, and then we are going to do a usings and a setup tag. Do using do quote do alias HubSpot data sync dot repo. So every case will alias that. We'll also import ecto, import ecto query, and import HubSpot data sync dot repo case. So every case should be importing and aliasing these things. And then we're going to set up a setup block tags where it's going to have a PID from a ecto adapters .SQL sandbox start owner, the owner of the HubSpot data sync repo. It's going to be shared, where not in tags async. So it's going to be shared across anything without the tags async. And then on exit, we're going to do ecto adapters SQL sandbox stop owner, and we'll give it that PID, and then we will OK. And so in this way we set up where every test should be aliasing the repo, should be importing ecto and ecto query and our repo case. Then we needed to set up some process ownership using the adapters sandbox, do start owner on our repo, shared with not tags async, and then on exit we'll stop the owner and then OK. Okay, next we're going to make our Oban case test. So we're going to make a new file, call this consume contact worker test.exs. We'll def module if we get our autocompletes. Consume contact worker test. This is going to be in our HubSpot data sync program. And then we're going to alias HubSpot data sync dot HubSpot client. We're going to use ExUnit dot case, and this one is going to be an async true. We're going to use mimic. We're going to use Oban dot testing with our repo Oban HubSpot data sync dot repo, and we're going to use HubSpot data sync dot repo case. And then for our first test, we're going to test that we can enqueue the Oban job. Where to do this test, we'll do an assert we'll get an OK and a job from Oban, HubSpot data sync dot consume contacts worker dot new, where we'll give it some empty arguments, and we will Oban dot insert that. So then we get our OK and our job. And then Oban provides some testing stuff for us, so we can do an assert enqueued. And we'll give it the worker, our HubSpot data sync dot consume contacts worker with the args that, our empty arguments. So in this test, we're testing that we can enqueue the job, and that the job is enqueued with our worker and their particular arguments. We can test this by doing mix test. Test helper.exs does not exist. Oh, because I called it test helpers, not test helper. So we'll call it test helper. And boom, looks like our tests worked. We have 1 test, 0 failures. Is that right? I'm sorry, I had that set up wrong. We needed to do mix env test mix ecto create to make our database. You can see that here, where we say that the database has been created. And then we needed to say ecto migrate in our test environment. So then we have our things, and now we've got 2 tests that are working. So now that we've got that, we can continue on with the rest of our Oban tests. Alright, so we'll do our next test. This test, we're going to test that we can execute the job. This proves that it works. So we'll do our HubSpot client. We will have an expectation on it where it'll retrieve contacts. This is our mocking. We're going to say that it'll return an OK with a map that has a results, that'll have some object that'll have an ID. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. And it'll have some properties, which will just have be an empty map. Next, we're going to assert that we get an OK and an OK contact. When we perform the job, HubSpot data sync dot consume contacts worker with our blank argument and no options. And the contact, we're going to assert that the contact has an external ID that is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll go ahead and test that. Retrieve contacts. Oh, I misspelled that. There we go. We got another test passing. We'll move on to our next test. Okay, next we're going to test that we can enqueue the next page of records. And we'll do our HubSpot client. Once again, we're going to do an expect, so I'm just going to copy it from the prior test. And in this, we're going to get not only a results, but we'll also get a paging, which this will have an argument that'll have a next with a object that'll have an after. and we'll just say after 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we will do an assert. We'll assert that we get an OK from perform job, where we'll give it our HubSpot data sync dot consume contacts worker with our arguments, no options, and then we're going to assert that we have enqueued our worker. And in this assertion for the enqueue, we're going to make sure that the arguments of this worker have a next and an after, which should contain our 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll go ahead and test that. Cool, looks like that's working. We'll move on to our next test, where we test that errors happen when HubSpot doesn't work. Alright, and for the last test, we're going to do if HubSpot doesn't work. So we'll do a test, error when HubSpot doesn't work. We'll do our HubSpot client, but this time in our expectation, we're going to get an error 500. And what we expect in our assert is to get an error 500 when we perform the job we can go ahead and mix test, and we see 5 passing tests, so we're doing good. Next, we're going to make a test for our HubSpot client, and at which point I will declare the video done. Okay, now last we're going to work on tests for our HubSpot client. We're going to go and make a new file, call it HubSpot client test.exs. We'll do def module HubSpot data sync dot HubSpot client test, and then we'll alias HubSpot data sync dot HubSpot rate limit. We'll alias our HubSpot data sync dot HubSpot client. We'll use ExUnit dot case async is true, and we'll use mimic, and then we will describe our retrieve contacts function. First, we're going to make a test where we can say that we can just retrieve the contacts. So we'll test can retrieve contacts do, and in this one we're going to take our Tesla, which we're mimicking with mimic, and we'll make an expect where we'll say on the get function, which will take in a client, a URL, and options. We'll say that this will give back an OK, Tesla.env, and in our Tesla env it should have a status 200, and it should have a body with that should be in JSON. So we'll JSON.encode our HubSpot response, going to be our paging with a next key and an after. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a results that's going to have an object with an ID 2, 4, 6, 8, 1, 0, 1, 2, 1, let's just do it 1, 2, 3, 4, 5, 6, 7, 8, 9. And properties, we'll just leave blank. So our Tesla will give us that back, and then we will just do an assert that we get an OK, and that this should be a Tesla.env from our HubSpot client dot retrieve contacts. That should work. Let's go ahead and test that. Okay, that's not what we got. We got a JSON string. So we'll just say JSON string, and maybe we can assert string dot contains JSON string contains our 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool, that works. So let's continue moving on and making the rest of our tests. Alright, and let's just write up our last test here. We're going to do a test errors from non-200 status. And here we're going to do our Tesla. We're going to expect on the get. Again, we got our client URL and options. What we are expecting is an OK and a Tesla.env with a status 500. And I am just going to copy and paste this body from my reference project because it's kind of a long one. And then we will assert that we get an error with the body from HubSpot client.retrieve contacts. You could also say that the assert that the string contains in the body the word validation error. I guess that's 2 words, but there's a little hyphen, a little underscore, if you will. Let's go ahead and mix test. Let's see. Validation error. Oh, because this is not encoding like this. So let's just make it JSON.encode and then test. Cool. So now we've got a whole bunch of working tests. And this also kind of effectively finishes this project. Thanks for watching. Have a great day.